In today's lesson, we're going to solve systems of equations algebraically. This is really the most efficient way to solve a system of equations. So a system of equations means you have two or more equations. One way to do it is by substitution. Substitution by definition means that I'm going to take one item and replace it in another. So this top equation tells me that x is equal to 10 minus 2y. I know what x is. It's 10 minus 2y. That same x shows up in the second equation. So I can take this 10 minus 2y and substitute it in. This becomes 4x, where x is that 10 minus 2y, plus 3y is equal to 10. Now I have one equation with one variable, and I can solve for y. Distribute the 4, so it's 40 minus 8y plus 3y equals 10. And go ahead and solve for y. This is my solution solving for y, and I've got that y is equal to 6. I'm going to do substitution again because I need to know what x is. Well, I know that x is 10 minus 2y, so I can take that my y is 6 and substitute it back into that first equation. So x is equal to 10 minus 2y, which is 2 times 6, which is equal to 10 minus 12, and x is negative 2. I'm going to write my solution as an ordered pair. If I were to graph these two lines, they would cross at the point negative 2, positive 6. And that is solving the system by substitution. Go ahead and give letter B a try. Substitute the y, which is that 3x plus 2. Substitute it into the top equation. Push pause while you do your work, and then when you're ready, resume play to check your answer. Here's my solution. In blue, I solved for x. I substituted in 3x plus 2 for the y. If it helps, you can put a 1 in front so that you remember that negative is distributed to both terms in parentheses. It was minus 3x minus 2. I solved for x, and I got negative 3. Then I needed to find y, so I took that negative 3 and I put it back into one of my equations. I put it into the one that said y equals, since I want to find y. I solved for y and got negative 7, which makes my solution negative 3, negative 7. And that's the ordered pair. If we graph the two lines, that they would cross at that point. So sometimes the equations aren't set up where it says x equals or y equals. In that situation, we're going to solve them by a method called elimination. And some books also call it the addition method. It's called the addition method because we add the two equations together. If I add these two equations vertically, x and x gives me 2x. And when I add the y's, plus y minus y, they cancel each other out, or it's eliminated from the problem. Then 12 plus 2 is 14. Now I have one variable. I can solve for x. and x equals 7. You do need to know what y is, so take that and put it into one of the two equations. It doesn't matter which one. I'm just going to do the top equation. So x plus y, 7 plus y equals 12. Subtract 7 from both sides, and y is equal to 5. The solution set is 7, 5. So elimination's nice for those times that you don't know what x is equal to or y is equal to. So let's try it again. We'll make it just a little bit harder. This time, if I were to add these two equations together, I have 3 plus 1, which ends up being 4x. 2y and negative y leaves me with y and 7 and 4. If I add them just the way they are, I don't get rid of a variable. Nothing is eliminated. And that doesn't help me. But what I can do is if this y was 2y, then they would cancel each other out. I can do that legally as long as if I multiply this by 2, I multiply everything in that equation by 2. So that top equation becomes 2x minus 2y equals 8. The bottom equation doesn't change. And now I can add the two together, and the y's are eliminated. Solve for x. X is equal to 3. So again, we can do this. You can multiply an equation by anything as long as you multiply everything in the equation by that same number. Now to solve for y, take the 3, put it back into one of the equations. This is called back substitution. Substitute it back into one of the originals. So I get 3x, which is 3 times 3, plus 2y equals 7. And now I can solve for y. Here's my solution, getting me to what y is equal to. Bring the two of them together. My solution set is 3, negative 1. And again, I could put each of those equations in slope-intercept form, graph them, and this is the point that the two equations would cross. Great, so I have one more for us to do, and we're going to make it yet just a little bit harder. This time, when I add things together, nothing cancels. But there's also no quick and easy way to make it all work out. So a trick that you can do is you can take the coefficient of one equation. So let's say we're going to get rid of the x's. I'm going to take the 8 and multiply it to the top, and the 7, multiply it to the bottom. What that does for the x's, it gives me 56 for both of them. But in order for those to cancel out, one is positive and one needs to be negative. So I'm going to multiply this by negative 7, making it negative 56. And now if I add those together, I can see that they will cancel. So I multiplied the first one by 8. Now you need to do it to the rest of the equation. So it's 56x plus 40y equals 16. And do the same thing to the bottom, but now with negative 7. 7 times 9 is 63. Two negatives make it positive. And negative 7 times 17 is negative 119. Add those together. The x's cancel. I get 103 is equal to negative 103 and divide by 103. Y equals negative 1. I'm going to substitute, back substitution, into one of my original equations. I'll just go with the top one. 7x plus 5y equals 2. I know that y is negative 1. And I'll substitute it in and solve for x. I solved for x here. I got x equals 1. Bring both solutions together, and my ordered pair is 1, negative 1. And that is solving by elimination. I have one more type of problem to go over. Take a look at this one. I'm going to solve it by elimination. I can see that I've got a negative x and a positive 2x. So I'm going to multiply this top equation by 2, and that will give me negative 2x, and then the bottom number is 2x. And I can see that they'll cancel. So I'm going to go ahead and multiply that out to the whole equation, and negative 4. My bottom equation was 2x minus 2y equals 0. When I add these together, the x's cancel, but so do the y's. That leaves me with a 0 on the left-hand side. Negative 4 plus 0 is negative 4. My solution is 0 equals negative 4, which doesn't make any sense. This is a case where it's a no solution. It makes no sense. It's no solution. And what that means is that my two lines are parallel. They have the same slope. They never cross. Therefore, there's no solution. On the other hand, if I solve this one through elimination, I see I've got a 12. I know I can multiply 4 by 3 to get 12. So I'm going to multiply by negative 3. That gives me one of the numbers as negative and one of the numbers as positive. So let's distribute the negative 3 out. It becomes negative 3y. And 6 times 3 will be negative 18. My bottom equation, 12x plus 3y equals 18. Now when I add these together, the 12's cancel, the y's cancel, and the 18's cancel. This leaves me with 0 equals 0. That's always true. This is infinite solutions. This is infinitely many solutions, which means that they are the same line. So if you have two different lines and they cross, that's one solution by substitution or elimination. If you have parallel lines, they'll never cross. That's no solution. And sometimes when you solve, you find out they're really the same equation, infinitely many solutions, and it means it's the same line. So that is an overview of substitution and elimination.